All right. Well, it's good to see everybody today. Hope you had a good first day back. Just a couple of things that are going to be happening, in the next couple of weeks because we're looking towards the end of the semester now. It's going to be happening actually really quickly. Tomorrow, you're going to have our first quiz this week, and it's going to be set up just like the focus activity yesterday. I'm going to give you some kind of transform function. You'll go ahead and find me, the midline, all the way through the frequency, sketch it, fill in the table, just like we did yesterday. So it shouldn't be anything surprising. Remember, you can always use your notes, so you can use that focus activity and the rest of your notes to kind of help you along with that. So that's happening tomorrow. Now, on the horizon, it's still next week, but it's going to be here pretty quick. What's happening next Friday? That's your second exam, okay. So I've already started creating it. I have not finished it yet, but I'm really pulling from this particular lesson we're on, graphing the other four trig functions and graphing sine and cosine. Now, it looks like it's going to take us probably at least through the end of this week to go ahead and finish up the lesson, just in case anybody's having a little bit of issues sketching these, and that's what I'm really looking for. But I don't think we'll be able to start the next lesson, which is inverses, until next week, so I'm not putting that on the test. So I might go ahead and put some throwback problems on there just to kind of give us a little bit of review, like law of cosines, law of sines, probably on there. What's that, Neil? Multiplication by 2. There you go. Well, some of these, involve those algebra skills. Exactly. So that's coming up next week, and I'll have more information as we get closer to it once I actually finish creating the test, which, knock on wood, hopefully will be by the end of today. If not, hopefully tomorrow. We'll kind of see. But I think that's all I have, unless anybody has a question. We've got a quiz tomorrow, test next week. We're back to our focus activities. What's that, sir? Do we have proof that the moon's real? I don't know. I mean, I know there's a society of flat earthers who believe that the earth is flat. You believe the earth is flat? Kudos to you. Yeah. So I don't know. I mean, honestly, a lot of people think that, for example, the moon landing was faked, but I think you are? They got it all wrong. They got it all wrong. The moon's real. We're living on it. Oh, twist. There you go. There you go.
It's not flat. I'm not sure if I already talked about this in one of our other flat Earth conversations,
Uh-huh.
but they think that Australia is not real, and that the Earth is actually not a circle or it's not flat. It's a donut shaped.
Really?
Yeah.
Really?
Yeah. Yeah.
Interesting. I never want to put myself in a position where I feel like I'm judging other people, but sometimes I watch the news and I see what's going on in our country and I look at our president and I'm kind of wondering, how can people still willingly support and back what he's doing? And then I think, okay, there are people who believe the earth is flat and all this other stuff, and it just kind of makes a little more sense to me. Like I said, not that I'm stepping on anybody's toes. If I am, I'm sorry, but okay. Ow. All right, so, all right, here's my next focus activity. This should be another really good grade, going into the end of the semester. At this point, we really want to make sure, all these last grades, if it's a homework assignment, quiz, test, try to do the best that you can on these because all of those are going to help determine what that semester grade is, and I want everybody to make sure that you're able to pass. And there's still plenty of time. In fact, I've got a plan for the test next week I think you're really going to enjoy. But let's see what our problem says. During a figure skating routine, Jackie and Peter skate apart at an angle of 15 degrees between them. Jackie skates for 5 meters and Peter skates for 7 meters. How far apart are the skaters? Now, one thing I always like to do if it's not provided, what do you think? Yeah, draw a picture. Kind of visualize what's going on. So let's say right here, they're both standing right next to each other. So Jackie skates off in her direction. She goes for 5 meters. Peter decides to go off in his direction. It's going to be a little longer because he skates for 7 meters, and we're told that there is a 15-degree angle between them. And the question says, okay, once they go this distance, the respective distances, what's the distance between them when they stop? Okay, so we got a triangle created here, and this is one of those review problems that I was referring to. Will I be able to use the law of sines or the law of cosines? Why not sines? There's not a pair, that's exactly right. In order to use the law of sines, I need an angle and the side length across from it. So without that, I got to use the law of cosines. Now, I'm trying to solve for x. So can anybody help me remember? I need an equation that's going to help me do that. Okay, Brandon?
We just go ahead and put the big A in front of the 15 and have I don't know, you know what I mean?
So you want to call this vertex A?
Yes.
Okay.
Okay, so we could do.
So I guess I would change this to little a.
So we could do a like little a squared.
Okay. So he says little a squared.
Equals 7 squared plus 5 squared minus 2 times 5 plus 7.
5 plus 7?
5 times 7.
There we go.
And then times the cosine of theta.
Which is 15 degrees. That's exactly right. That's the pattern. Okay. We start with one side. Okay, so we're looking for a squared. So we take the other two sides, we squared them, we added them. Minus 2 times the product times the cosine of that angle we have. All right. Now, that's going to give me a squared, but I want a. So what am I forgetting? Yeah, take the square root. So when I go to the calculator, I'm going to go ahead and type in this entire expression as I have it. So let me get rid of those inverses real fast. So I've got one big radical. I've got 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 15 degrees. Now again, make sure my calculator's in degrees. We don't need to change it to radians. So when I push enter, let's see, Jackie and Peter should be about 2.5 meters away from each other. Okay, about 2.5 meters. All right, there we go. So I'm thinking as part of your test next week, I'm making some of it open-ended where you got to write the answer, and then some of it's going to be multiple choice, just like it always is. But I'm thinking about putting a few of these on there as well, since we won't really be able to get to the inverses just yet. Okay. Well, good. Now we have 2 of those. Go ahead and put that one with the first one. And let's see what we got here. All right, so just a quick recap. Yesterday, at the top of the lesson, we were talking about sinusoidal functions, and that's just any transformation of sine. But any of the trig functions can be referred to as sinusoidal functions. Somehow, some way, you can relate all of them back to sine. So we just call that a sinusoidal function. And then we introduce this idea of frequency, which is b, the coefficient of x over 2 pi. It's the reciprocal of the period, okay? And then we started talking about tangent. And we ultimately ended up with the graph of tangent here. And I really need to be careful today because my tan line is showing. My tan line is showing. No? No response off that, really? Okay. My tan line. Like tan line. Okay. All right, I got some better ones. Why did you make that joke, Mr. West? Well, just cause. Okay, well, keep going. Yeah, I kind of figured you guys didn't get a lot of that over the break, and you probably wanting it when we come back. So, yeah, okay. All right, so a couple things. Now, tangent and cotangent, their period is only pi radians. So it's only going to take pi units for the graph to start repeating over and over again. Now, tangent and what you're going to find with cotangent, they have asymptotes because there are places where tangent is going to be undefined. For example, if you take a look right here, tangent's undefined at pi over 2, right? Well, if we go ahead and investigate that, and we kind of did this yesterday, but I'm just kind of bringing everything together. Let's go ahead and look at pi over 2 right here. Now remember, tangent always wants to take the y and divide it by the x, right? So this ordered pair, the 0, 1, I'm going to take the y and divide by the x, but remember we can't divide by 0. So that's why we have asymptotes. There are places where tangent can't be evaluated, and that's why you'll be dividing by 0. Now, one of the other things we brought up, in one period, we still have those 5 critical values. Okay, like for sine, remember it was a 0, 1, 0, -1, and then 0. You know, cosine has his. Well, tangent's going to have his own, just like those. But we're only going to be looking at one period. So what did we use to show that asymptote? What symbol did we use to show that we were just starting with an asymptote? Oh, not theta. It was 0 with a slash through it. Yes, the no solution symbol. There we go. Oh, theta is if you draw it horizontally. Okay. So now, as we go along the curve, remember we were looking at the y values of the 3 points we left. So it had -1, 0, and then 1. -1, 0, 1. And then we finish off the period with another asymptote. Okay. Now, the one thing we're about to go ahead and do today is start sketching tangent. And we'll also get to cotangent as well. But we're going to have to use the asymptotes in order to help me here. Now, as long as you have a consecutive pair of asymptotes, consecutive pair of asymptotes. Okay. Now, what am I talking about when I say consecutive? Like, what are consecutive numbers? Yeah, numbers that are in order, right? So I'm just looking for a pair of asymptotes that are right next to each other. Now, what we like to use when it comes to tangent, we like to use -pi/2, and we like to use pi/2. Okay. With tangent and cotangent, we have to use consecutive asymptotes. So let's just get right to it. Here's our example. Use transformations, graph each function, state the period, and show all the asymptotes. So we want to transform just the tangent function into -2 tangent of 1/2 x. Okay. So I have an a. I have a b. What's the value of c? There is no c, so it's 0. What about d? 0. Okay, so there are no c and d to worry about. Now, here's what we're going to do. You remember when we were graphing sine and cosine? Just like you're going to do on your test tomorrow, or your quiz, I should say. You start with a compound what? Remember, compound inequality. We always say less than or equal to, less than or equal to. What goes in the middle? Yeah, whatever's in parentheses. Remember, those are the horizontal transformations, right? So in between here, I'm going to put x over 2. Well, here's the one difference, and it only applies for tangent and cotangent. You have to use your lower and upper boundaries as that consecutive pair of asymptotes. So if it were sine and cosine, I'm going to put in 0 and 2 pi, no problem. But if we're dealing with tangent, I need to use a pair of asymptotes that are right next to each other. And you can use any pair that you want. I think it's going to be just the easiest to use -pi/2 and pi/2. Okay. Right there. Okay. Everything else is going to be the exact same strategy. Okay, now, Nathan, you were saying something? Yeah, because I still want to get just a single x in the middle, right? Okay. And Nathan is saying I just need to multiply through by 2. And I'm going to do that. I'm going to multiply the whole expression through by 2. So let's see. That would give me -2 pi over 2. So that's just -pi. Then 2x over 2, well, that gives me the 1x. And then 2 times pi over 2, that's just pi. All right. Perfect. So there's my compound inequality. The only difference is we're just starting with a different upper and a lower. That is the only change in the process. Now I want to go ahead and take a look at my critical values. Remember the critical values that we just listed for tangent. It's this guy right here. Okay. Uh-oh. Can you hear me now? Yes. So -1, 0, 1, and there we go. And what does the no solution refer to again? What's that mean? That's where the asymptote is. Remember, again, this is one period of the graph. These are my 5. We'll always use these 5. Now, here's my question. Is there anything happening outside the parentheses that would change these?
Yes.
There you go. Remember, anything happening outside the parentheses, that's vertical. That's what's going to apply to your critical values. So every one of these, I just want to multiply by a -2. So -1 times -2, well, that's just 2, right? 0 times -2. 1 times -2. So those are easy enough. What's undefined times -2? Oh, not 0. It's still, it just remains undefined. Okay. So you see how I went ahead and changed my critical values based on the vertical changes?
Yeah.
Okay. So these are the y values that I want, just like we've been looking at. Now the x values are coming from this compound inequality. But how do I match these guys up?
So that negative like so you're what are those called like
Yeah, the lower and the upper.
So the lower you put it with the first asymptote and the
That's exactly right. The lower boundary, whatever I end up with, I'm always going to pair it with the first critical. The upper boundary, I'm always going to put him with the last one. Okay. Now here you'll notice, and I mentioned this yesterday, the lower boundary didn't become 0, like when we were dealing with sine and cosine. So I need to know the distance here. How far is it from -pi right here to pi? It's 2 pi, right? So sometimes you might have to subtract the 2 in order to get the distance. Once you know that distance, we always, always, always divide by what? 4. We always, always divide by 4. Okay. Will we always divide by 4?
Yes.
Always. Okay. Now, this is going to help me fill in these 3 missing x values. I already have the lower and the upper, based on the compound inequality. So now I just want to add pi over 2 over and over again. So what's -pi plus pi over 2? And if you're thinking here, just look at it graphically, we're going -pi, and I want to go pi over 2 to the right. See, I'm at -pi over 2. Now, what's -pi over 2 plus pi over 2? Yeah, see, now I'm to 0. What's 0 plus pi over 2? Pi over 2. And remember, this should always happen. What's pi over 2 plus pi over 2? Pi. It should always, always match up with your upper boundary. No. If it doesn't match up, that means we made a mistake someplace. Okay. Now, normally when we've been dealing with sine and cosine, we've had 5 ordered pairs. Here, I actually technically only have 3. The first ordered pair would be this one. So -pi over 2, 2. Because again, we have our x's and y's, right? So I'm going to go ahead and locate those points. -pi over 2, 2. So from the origin, I'm going to go left and then up. Then I have 0, 0. And then I have what? Pi over 2, and then -2, right? How will I graph this? How would I graph -pi undefined? Remember, what does the undefined represent? So there you go. So this is telling me exactly where my asymptotes have to be. I should have an asymptote at -pi and one at pi. And now just connect your dots. It is the same strategy we've been using for sine and cosine. The critical values are different, and we start with a slightly different compound inequality, but beyond that, the steps are the same. And remember, we could even go ahead and repeat this. Let's see how far it goes. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to take 8 units to get to the next asymptote, right? But it's only going to take 4 to get to the next intercept. So from the asymptote, I can go 1, 2, 3, 4, and then I can just copy the pattern. 2 left, 2 up, 2 down, 2 right. You'll just follow the pattern if you want to get another period. Okay. How we doing? Anybody confused? Okay. All right. Okay, let's go ahead and try another one. We got one right next to it. Tangent of pi over 4x plus 2. Okay, so let me go ahead and take this off real quick here. Oh, and one thing I forgot to mention, what's the period, the formula for the period? It's 2 pi over b, right? But tangent and cotangent, they're different than the others. They're special. For the period, you'd have to take pi over b. Because for sine and cosine, their period is 2 pi, right? But for tangent and cotangent, their period is only pi, and it's really easy to forget. Okay? So in this case here, I'm going to take pi over, well, b is 1/2. So it would be 2 pi. So this graph would repeat every 2 pi radians. Okay? All right, let's go ahead and try this one. Tangent of pi over 4x plus 2. All right, let's go ahead and start with the compound inequality. Okay, now there's no parentheses here, so I'm still going to go ahead and start with negative pi over 2 and pi over 2. For tangent, we're going to be very specific about that. We need a consecutive pair of asymptotes. For sine and cosine, we'll go 0 to 2 pi. Okay, now even cotangent will have something different, but that's the only ones that are going to change. Now, what am I going to put in the middle here? Oh, you're forgetting one detail. It's not just x over 4. It's pi over 4x. Now, see, here's the thing. Would that 2, would he be a phase shift left or right, or is he up or down? Okay, so I heard left and right, and I heard up and down. Why is he up and down? There's no parentheses, right? But how do I still know, even without the parentheses, pi over 4 has to go there? What is he directly connected to? He is directly connected to x. Now, if I was meant to put the plus 2 in there, then there would be parentheses to show me that. But without the parentheses, that means the 2 has to be vertical. Okay? Is everybody okay with that? All right. Well, what I need to go ahead and do is get x in the middle, just like we did a moment ago. Well, let's see. Is there anything I can multiply by that'll help me do this? And we can do it in 2 steps, or we can do it in 1 step. What do you guys prefer? You want to start with 4? You could. You could just multiply through by the reciprocal. But does anybody want me to do it in 2 steps? Okay. So Nathan, his first idea was just go ahead and multiply through by 4, right? So if I multiply here, this would be negative 4 pi over 2, which would be negative 2 pi. Okay. Now, what's 4 times pi over 4? Yeah, the 4's would cancel, and I still have pi x is less than or equal to, okay, 4 pi over 2, which one again give me 2 pi. Now, see, we're getting closer. I've got pi x, but I just want x. So now divide by pi. Okay, so let's see. This gives me the x I want in the middle. 2 pi divided by pi. 2. Negative 2 pi divided by pi. Negative 2. Now you'll notice pi completely dropped out of this. And you'll notice what have I done for us on the grid. I'm always going to make sure that the grid should fit the function you're working with. Okay. So if there's no pi, we don't need pi to be there. Okay. We had enough pi over Thanksgiving. Man, it's a rough crowd today. All right. But is everybody okay with how I did this? And remember, Brandon said if you just want to go ahead and multiply through by 4 over pi, you would have gotten the same thing in 1 step. It just depends on how comfortable you feel. Okay? All right, so I've got this. Now I'm going to put him to the side. Let's start with the criticals now. What were the 5 criticals for tangent? No solution. -1, 0, 1, no solution. And we already kind of brought this up. What am I going to do to each of these? I'm just going to add 2. That's the only thing happening besides that 1/4 pi we got. Okay, well, let's start with the actual numbers. What's -1 plus 2? 1. Okay, 0 plus 2 is 2. 1 plus 2 is 3. Now, what would undefined plus 2 give me? It's still undefined. So that will stay the same. That will stay the same. So these are the y values that I need. Is everybody okay? Right. So let me remove those. Well, how do I get my ordered pairs using those and my compound inequality? Okay. So Nathan says this lower boundary, I'm going to pair with the very first one. And the upper boundary, I'm always going to pair with the last. That's always the same. There you go. So how far is it from a -2 to a +2? It's 4, right? The distance there is 4, but then what do we always do to that distance? Always divide by 4. So what am I going to be adding over and over again? 1. Everybody okay with how I'm getting this? Anybody not sure? Okay. So let's see. What is a -2 plus 1? And will 1 plus 1 give me 2? Yes. You should match up to your upper boundary every single time. If you don't, we've made a mistake someplace. Okay. So how many ordered pairs did I actually give myself? Okay, 3. Because what are the other 2? The other 2 are the asymptotes. In fact, I know that there's an asymptote at -2, and I know there's an asymptote at +2. Okay. And let's see, what's one ordered pair that I have? Yeah. So there's my x's and that's my y. So -1, 1. Then the second order pair would be 0, 2. And what's my third ordered pair? 1, 3. There you go. Okay. Now, just like with sine or cosine, if I wanted another period, I just repeat what I see. How far apart are the asymptotes from each other? Yeah, so 1, 2, 3, 4, right? So where would the next one be? Yeah, so the next one would be at 6. So I know there'd be an asymptote right there. Now, just follow the dot pattern. Halfway between, I know we'd go 2 up. So halfway between, I go 2 up, and I just follow that pattern. There you go. And I can even do the same thing in the other direction if I wanted to. This strategy will always give you one full period of your graph. You then just have to copy it, one more time. How we doing? Okay. All right. Well, let's switch gears a little bit. Okay. That's tangent. Now, I want to show you something quickly on tangent that we did before. You remember in order to get his graph, I rewrote tangent as sine over cosine, right? Okay. Well, what we're going to do now is something very similar for cotangent. He's the reciprocal of tangent. Okay. So let's start with cotangent. Now, if you remember his ratio, he's always x over y, right? The adjacent over the opposite. Well, we know by now what trig function is x. Cosine. So I'm going to replace him cosine x over. What trig function is y? Sine of x. So which one, sine or cosine, do you think I'm going to use to help me with cotangent? Now, why sine?
Because it's the opposite of tangent.
There you go. It's a reciprocal, and more importantly, he's in the denominator. So let's go ahead and graph sine. And we're going to do this lightly, because we're going to go ahead and erase it. So sine always starts with a 0, then goes to a maximum, 0, minimum, 0. Back in the other direction, minimum 0, maximum 0. Okay, so there's sine. Graphed it just like you told me to. Right? Okay. Now, what's the one thing that we can't divide by in a fraction? You can't divide by 0. Well, how do we know where sine is 0? Wherever he what? Wherever he touches the x-axis. So, for example, cotangent, he's going to be undefined at negative 2 pi, because see, that's exactly where sine touches the x-axis. Where's another one? I've got the first one at negative 2 pi. Negative pi would be another one. Then 0. Then we have pi. And then we have 2 pi. See, once you have your asymptotes, this is when I'm going to go ahead and erase sine. He helped me figure out where he was undefined. And remember, these graphs are always going to be symmetrical. Okay, so where do you think the x-intercept is going to be? Oh, not 0, because that's where we have an asymptote. So you take a pair of asymptotes and go halfway between. So what's halfway between 0 and pi? Pi over 2. What's halfway between pi and 2 pi? 3 pi over 2. So exactly halfway between each pair of asymptotes, that's where my intercepts are going to be. Okay. Now you remember with sine, or with tangent, if you look at the graph, the patterns went up to the right. Okay. Well, with cotangent, remember this is the reciprocal. So you're going to see this pattern. So instead of rising to the right, it's going to fall to the right.
So, like, when we're taking the zeros, do we have to pi or something? Because isn't there more zeros than
Oh, yeah, this graph is going to continue.
you know, like, there's more zeros,
More zeros in between.
right? As it goes to 0, maximum, 0, minimum.
Oh, yes, but this one's going to be slightly different.
Like, so,
Because remember, he's the reciprocal.
yeah, so we only take, like,
You're still only going to take 5. It's still going to be from one asymptote to the next. So this one here, this intercept, I'm going to go to the left 1, 1 up, to the right 1, 1 down. Left 1 up 1, right 1, 1 down. I'm just going to follow that pattern over and over again. Okay. And this is cotangent. Okay. This is the reciprocal of tangent. Now, I want to go ahead and take a period and, again, show you why we have the points that we do. Let's go ahead and use this positive one right here. That period. Again, just like tangent, his period is pi. It only takes him pi units to repeat. Okay. Well, what's this right here, halfway between 0 and pi over 2? Oh, between 0 and 1/2 pi. 1/4. So this is pi over 4. And what's halfway between pi over 2 and pi? That's 3 pi over 4, right? Okay. So why don't we go ahead and look at the unit circle. Let's take it in increments of pi over 4, starting with 0. Now at 0, cotangent has a what? He's got an asymptote there, so there should be a problem. Let's go over here. Remember, cotangent wants me to take the x value and divide by the y value, right? So let's start at 0. See, I'm going to take the x and divide by the y, but what's 1 divided by 0? Okay, undefined. See, that's why at 0, we start with an asymptote. Now let's go ahead and rotate to pi over 4. Okay. At pi over 4, here I want to take the x and divide by the y. Yeah, well, that gives me 1. So I would have the ordered pair pi over 4, 1. Which, if you look here, see, I have pi over 4, 1. So the next point, I've got pi over 2, 0. So let's check pi over 2. At pi over 2, what's the x 0 divided by the y 1? 0. So see, we have pi over 2, 0. Go to 3 pi over 4. Again, I want this x divided by this y. That would be negative 1. And then what happens when I go one full period for cotangent? What is negative 1, that x, divided by y 0? Undefined. And now look at our graph. At 3 pi over 4, it gave me negative 1. At pi, we have an asymptote. In fact, can anybody give me what they believe the 5 critical values are going to be for one period? We start with an asymptote. Positive 1, 0, -1 asymptote. Yes. Just imagine you took the critical values for tangent and you just flipped it. Or it's like you took the reciprocal. Okay. There you go. Okay, and then I've got some characteristics down here. The domain is all reals except the asymptotes. So you're going to find those in multiples of pi. Okay. Here are the intercepts. The range is infinitely tall, just like a tangent. Okay, now here originally there is no y-intercept because the y-axis starts off as an asymptote. It also has odd symmetry as well. That means it's symmetric to the origin. Okay, very good. Now remember, every other radian measure is going to have a place on this as well. Okay, that's how we're able to get the smooth curve. But we're going to go ahead and start out the exact same process to graph cotangent that we did tangent. There's just one difference. Remember I said for tangent and cotangent, you have to use a pair of consecutive asymptotes. Well, look at cotangent. He doesn't have the same asymptotes that tangent does. So I would go ahead and use 0 and pi. So like on this problem at the bottom of your current page, if I want to go ahead and graph cotangent of 2x, when I'm going to go ahead and create my compound inequality, I'm still going to put the 2x in the middle because the 2 is directly connected to x. Okay, but my pair of asymptotes, I'm going to say 0 and pi. Tangent and cotangent are the only two functions where that inequality is going to be different. For tangent, we're always going to use negative pi over 2 to pi over 2. For cotangent, we're always going to use 0 to pi. Okay. All right. So I'll tell you what, I've got 12:30. You guys have done a great job today as always. We'll just go ahead and stop there and pick up with this tomorrow. Now remember, tomorrow we are going to continue, but we also have a quiz. Yes.